Can you hear me? Can you hear me? Okay, any doubts? Any doubts from the last class? Any doubts from the last class? Okay, so now we will continue with motion. We will study. We will actually study kinematics, right? So topic is okay. So we will study motion. So motion, right? I think you know what is motion. If I ask any one of you, you'll be able to tell me what is motion, right? I hope. Right, motion is right when an object changes its position with respect to the surrounding, then we say that the object is in motion. Okay, when an object changes its position with respect to its surrounding, then we say that the object is in motion, right? Let me give you an example. Suppose you are traveling by a car on a road. You are traveling on a car, right? And suppose there is a person standing here, right? And you're sitting inside, right? So for him, you are in motion, right? For him you are in motion because your for him your car is changing its position, right, with respect to surrounding, right? If there is a tree here, let us say there is a tree in this side of the road. Let us say we have a tree on this side of the road, right? We have a tree. Then if your car will change position, suppose your car will reach here after some time, if it's moving, right? So you see, with respect to the tree, your car has changed position, right? It was here before, but now the tree is here itself, but your car has moved a little bit there, right? So he will see this. This person will see this. So for him, you are in motion. That means you are moving, right? For him, you are moving. But suppose there is another passenger sitting with you. There is another passenger sitting with you here inside the car. Right? So now you will constantly see this passenger here itself, right? He will not change position. He will be sitting there only, right? So in that case, you will say that this person is not in motion, right? He will not be in motion with respect to you, but with respect to this person here, right? Let us call this A. Let us call him A. So with respect to him, this person is in motion. This your fellow passenger is in motion, but with respect to you, he is not in motion, right, because his surrounding is not changing, right. So when we talk about motion, it's a relative concept. It's a relative concept. That means it depends on the person who is watching. It's a relative, understand? Is it clear? It's a relative concept. Okay, motion is a relative concept. For us for us, we don't see the earth moving. Can we see the earth moving? No, right? If we are on earth, we cannot feel the earth moving. We can feel it, but we cannot see it, right? So we will say that the ground below us is not in motion. But suppose somebody goes to another planet, let us say he goes to Venus or Mars. He goes to Venus or Mars and he watches from there, he will see that the earth is moving, right, because the earth moves around the sun, right. So in that way the earth is in motion, but with respect to me, the ground below me is not moving, right. So in the I will say that the earth is not in motion, right, but otherwise it is. In actuality it is, right. So it depends. So motion depends on the observer. Is it clear? That's what I'm trying to say. Motion is relative. Is it clear? Motion. Okay, so motion is relative, understand. Now in the same way, rest is also a relative concept. Rest, what is rest? See, when an object changes its position with respect to the surrounding, then we say that the object is in motion. So exactly opposite of this, rest is when an object does not change its position with respect to the surrounding, then we say that the object is at rest. Okay, so even rest is a relative concept. So this example that I gave of the passenger that is sitting with you, he is at rest, right? He is at rest with respect to you, but with respect to the person here, he is in motion. Okay, so rest and motion are relative concept. That's what I'm trying to say. Okay, is it clear? Is it clear? Any doubt so far? Yes, any doubt so far? Rest, explain again. Okay, rest again. So rest, okay, first of all, what is rest? Rest is when the object does not change its position with respect to surrounding. If the surrounding is same, right? If the person, suppose that again tree is here and another person is here, right? Tree is here and another person is here, and you are watching from somewhere. You are watching from somewhere, right? You are watching from somewhere maybe, right? And if you see that the person is always here, the person is always here, and the tree is also always there, and the gap between them is same always, then you will conclude that the person is at rest. That means the person is not moving, right? You can say that, yes or no? If the person is always there in front of the tree and the gap is always same, then that means the person is at rest, right? Okay, once the person starts moving, and let us say he has now reached here, right? Now the gap between him and the tree, there is some gap, right? His surrounding has changed, maybe something else is now in this place, maybe a building, right? His surrounding has changed, right? So when surrounding of a person changes, right, so we can say that the person is not at rest, but when the surrounding is same, then the person is at rest. Okay, so it depends on the viewer again. Okay, so like I gave example here, if you were sitting inside a car with a passenger, so if you watch that passenger, he is always at the same position, right? He is not changing, he is not moving around in the car, he will be sitting there only, right? But for a person who is standing on the road, right, for him this person is also in motion, right? Because the car is moving, so he is also at motion. Okay, that's what I'm saying. Is it clear? Is it clear? Is it clear now about rest or no? Yes, okay. Okay, now motion, now so rest and motion is clear, I hope. So motion can be of three types, okay, depending on where the motion is happening. It can be of three types. One can be one dimensional motion. Number one can be one dimensional motion. Other can be two dimensional motion, and the third one is three dimensional motion. Okay, three dimensional motion. Okay, so what is one dimensional motion? One dimensional motion, from the term itself you understand, one dimension means when the object or whatever you are watching is moving in a straight line, or in one path only, then we will say it is one dimensional motion. Suppose you are moving on a straight road, straight line, right? You are moving in a straight line, then your motion is one dimensional motion, right? And again another example, let us say you have a tree, an apple tree maybe, right? An apple tree, and the apple falls, right? So apple will fall straight in a straight line, right? So again this is one dimensional motion. Okay, understand? One dimensional means it's a straight line motion along a same road or same path. Okay, even a train moving on a railway track is also an example of one dimensional motion. Okay, now two dimensional motion, suppose you have a carom board, and you have dices here, right? These small dices. So now if you hit a dice, it will move around this computer table, it can go anywhere, not sorry, carom table, anywhere, right? So that is two dimensional. It's not a straight line motion, it's moving in a plane, it's moving in a surface, right? It's in a flat surface, right? So that is two dimensional motion. Another example can be an insect moving on the floor of a room, right? If you have an insect moving on the floor of a room, he is moving in a flat surface, right? So that is two dimensional motion, right? And three dimensional motion can be an aeroplane, right? Flying in the above the ground, can be an aeroplane flying above the ground, that is 3-dimensional motion. Can be a bird flying can be 3-dimensional motion. Mosquito can moving around can be 3-dimensional motion, understand. So why is this called 1-dimensional? Okay, so first of all, see, you have 3 dimensions. Okay, in the real world that we live, we have 3 dimensions. If you want to explain whatever we see in the real world has 3 dimensions, right? So you have something, for example, if you take a cube, let us say you have a box in the shape of a cube, right? You have a box in the shape of a cube. This cube you are seeing in 3 dimension, because you can see its length, also, you can see its height also, and you can see its breadth also. There are 3 dimensions of this, right? Understand? So that means to explain this, we need 3 axes, x, y, and z. Okay, we need 3 axes, x, y, and z. Sorry, not like this. X, y will be here, y and z. So these are 3 axes that help us to explain anything in the real world, right? If you see anything in the real world or any quantity in the real world can be explained in these 3 axes or 3 dimensions. These are the 3 dimensions, spatial axis. These are called spatial axis. Okay, a little bit about this you must have done in class 10, right? Coordinate geometry, x axis, y axis. If you remember, you have also a z axis. Okay, with x axis you can describe left right motion, y axis you can describe up down motion, and z axis you can explain into and away motion, right? Into the paper, away from the paper, that type of motion, understand. So now why do we call this 1-dimensional motion? Because here we can use anyone, we can use only x also to describe how this person is moving, right? Or we can use even y also, we can use only z also. Okay, we need only one, we need either x or y or z, we don't need more than one. Okay, but now 2-dimensional motion we need 2. Anything that is moving in 2-dimensional motion we can explain using these 2, maybe xy, maybe xz, maybe zy, right? So any combination, right? But for 3-dimensional motion we need x, y as well as z. If I want to describe aeroplane, let us say an insect is flying on the room, right? So the position of this insect, if I want to tell the position of this insect, I will have to use x also, I will have to use y also, I will have to use z also. Okay, I have to make use of 3 coordinates, 3 coordinates, yes, right? So 3 coordinates. So that's why this is a 3-dimensional motion. But a person that is moving in a road, I can easily tell everything about him just using x or y or z. Okay, that's why they are called 1-dimensional, 2-dimensional, and 3-dimensional motion. Is it clear? Yes or no? Is it clear? Right, you have to think about this, understand. It's very common sense, right? 1-dimensional, 2-dimensional motion, you don't have to learn the definition also, you will easily be able to identify what is 1-dimensional, what is 2-dimensional, what is 3-dimensional things and all that. Okay, understand. Now next thing, now there are 2 things that we have to learn: distance and displacement. What is distance and what is displacement? Okay, so to explain this, let me take a simple example. Let us say an object is moving, it starts from here and goes here, maybe, right? He starts from this position A, and reaches position B after some time, right? So if I tell you, if I ask you, tell me what distance did he move, what will you do? You will calculate that distance from A to B, right? You will go from A to B and calculate the distance, and you will tell me something, right? Maybe it can be any number, right? But what about displacement? Is it the same thing? No. Displacement and distance, they are not the same thing. What is displacement? Displacement is the shortest distance from the initial to the final position. Okay, displacement is the shortest distance from the initial to the final position. Which is the initial position in this case? This is the initial position, right? Initial position, this is the final position here, right? So shortest distance between this two, right? So what will be the distance between these two? This displacement, sorry, this is displacement. Okay, this here is displacement, and distance is actually the total path length. What is distance? Distance is the total path length, that is your distance, whereas displacement is the shortest distance from initial to final position. Okay, this is your displacement. Is it clear the difference between distance and displacement? Is it clear, yes or no? Can you tell me the, I mean, is it clear whether distance difference between distance and displacement is clear? Right. Okay, so that is the difference between displacement and distance. Okay, now one is here, distance is what? A scalar quantity. Distance is a scalar quantity and displacement is a vector quantity. So again, you must have done before also scalars and vectors, but still I'll explain. Scalars, what is scalar? Scalar, it's a quantity. Scalar is a quantity which can be completely described. Scalar can be completely described by its magnitude, right? And vectors are quantity, quantity which can be described using both magnitude and direction. So if you want to describe a scalar quantity, just magnitude, you just have to know the magnitude, but for a vector quantity you have to know the magnitude as well as direction. Okay, understand? So as an example here, displacement, so as I said, distance is scalar and displacement is vector. So distance is scalar means if somebody asks you the distance, you will just tell them the number. Maybe that number can be 200 meters, right? Somebody asks you how much distance did you move today, you will just tell them 200 meters. They will not ask you anything else. They have understood that you moved 200 meters, right? But when somebody asks you about displacement, in that case you have to specify the direction also, right? Along with the distance, maybe so let us say this distance is 50 meters, but along with this 50 meters you have to tell them the direction also. Okay, you have to tell them the direction also. Is it clear? That's what a vector is, that's what a scalar is. Understand? Scalars are quantity which can be completely described by magnitude. Only magnitude is needed to describe them, whereas vectors are something which have to be described with both magnitude and direction. Is it clear? Is it clear, yes or no, vectors and scalars? There is a separate chapter on vectors and scalars in maybe the next chapter, so we will discuss there. For now, just understand, I hope you understand what is the meaning of these two. Okay, so that is your displacement and distance. Again, there is two more things: speed and velocity. Speed and velocity. Speed and velocity. Again, see, again people confuse between these two, speed and velocity. They think that it is the same thing, right? Again, what is speed? Speed is the total distance divided by time, whereas velocity is total displacement, right? Velocity is total displacement divided by time, right? So again, look, this is distance, this is displacement, and I told you there is a difference between distance and displacement. So that's why these two things are also different things, they are not the same thing. Sometimes we interchangeably use them. In case at total distance, suppose a person is moving in a straight line, in that case what will happen? Distance and displacement is same, right? Distance is also from this to this, displacement is also same. In that case speed and velocity may be same, right? But we should not say that they are the same thing. Is it clear? Okay, so speed is total distance divided by time, whereas velocity is total displacement divided by time. Okay, one more thing, what is the unit of distance? Distance unit in SI is meter. Again, displacement is also has the same unit in SI unit. Okay, other units can be kilometer, centimeter, right? All those it can be anything depending on the system of units that you are choosing, right? So let us go with meter for examples. So okay, so again, look, if you want to find the unit of speed, it will be meter divided by the unit of time, which is second, right? So unit of speed is meter per second. Again, here meter, this is time, second. So again, same units, right? They have the same units, but they are not the same thing, because speed is a scalar quantity and velocity is a vector quantity. Okay, because velocity is a function of displacement, displacement is a vector, so velocity is also a vector, whereas speed is a scalar quantity. Okay, understand? Yes or no? Speed and velocity, the difference is clear? Speed and velocity difference is clear? Yes, is it clear? Okay, so that is thing. One more thing, see, another difference between distance and displacement is that distance is always a positive number, right? It can be 0, but 0 or more than 0, it will always be 0 or more than 0. Displacement can be negative, can be positive, as well as 0. Okay, distance can be negative, positive, as well as 0. Understand? Why negative? Depends on the direction. If it's moving to the, maybe you say this is your positive, and if something moves to your left, you can call it minus, you can give it negative number, you can say minus 2 meters, then the person will understand that the object was moving to the left. Okay, so this minus is just to give the direction in displacement. Okay, same thing applies to speed and velocity. Speed will be 0 or more than 0, whereas velocity can be 0, negative, positive. Okay, understand that thing? I need you to read about this. Okay, by now all of you must have books, so read about them. Velocity, distance, speed, integration, also you try to understand that again. If you have the I mean, you should have the books by now, so you read them. Yes, any doubts? Any doubts? Any doubts? Okay, just type in your roll numbers. 1 minute you have. Okay, so that's it for today. Any doubts that you have? Any doubts? Okay, okay, then see you. Bye. You can have a look at the videos again and again, okay, if you have any doubt. Okay.